Right now, as you're watching this, the moon is pulling on your body. Not just the ocean, not just the tides. You, every human being on Earth, is very slightly lighter when the moon is directly overhead. It's a tiny effect, but it's real. That's how strong its grip on us actually is. So here's the question. What happens the instant that grip disappears? No explosion. No warning. No asteroid strike. The moon simply isn't there anymore. Would the oceans go flat? Would our days get shorter or longer? Would life even notice? The answer is stranger than almost anyone expects, and one part of it, scientists spent 20 years getting completely wrong. Let's find out what really happens. The moon vanishes. Nothing crashes into Earth. No shockwave. No sound. That's because it's almost 384,000 kilometers away, nearly 30 Earths could fit in that gap. Gravity doesn't snap back like a rubber band, it just stops pulling. Earth keeps orbiting the sun exactly as before, like nothing happened. But something has already changed. You just can't see it yet. Look up. The brightest object in our night sky, gone. On a clear full moon night, moonlight is roughly 400,000 times dimmer than sunlight, but it's still enough to cast shadows, enough for you to walk a trail without a flashlight. That light is now gone completely. Not dimmed. Erased. And nature runs on that light. Dung beetles navigate using the Milky Way when the moon is absent, but countless other species aren't so lucky. Owls miscalculate hunting strikes. Coral on the Great Barrier Reef spawns in synchronized bursts timed to the full moon, a signal that just went silent. Sea turtle hatchlings, which crawl toward the brightest horizon, lose the beacon that's guided them for millions of years. Humans reach for a light switch. Nature has no switch to reach for. Now the oceans shift. Most people know the moon causes tides. Here's what most videos don't tell you. The sun causes tides too, about 40% as strong as the moon's. So tides don't vanish. They shrink to roughly a third of their normal range. Take the Bay of Fundy in Canada home to the highest tides on Earth, up to 16 meters. Without the moon, that number falls to around 5 or 6 meters. Still dramatic, but an entire ecosystem built around that extreme rhythm suddenly has the rug pulled out from under it. Mudflats that were exposed twice a day stay wetter. Species that fed in that narrow tidal window lose their timing. Fishing communities that have read the tides for generations have to relearn the ocean from scratch. The sea doesn't stop moving. It just stops keeping the same promise it's kept for 4 billion years. Here's the part almost every other video gets wrong. For nearly 20 years, the accepted story was this. The moon acts like a gyroscope, locking Earth's tilt at a stable 23.5 degrees. Remove it, and Earth's axis would swing wildly from 0 all the way to 85 degrees. Deserts freezing, ice caps at the equator, total climate chaos. That number 0 to 85 degrees came from a landmark 1993 study, and for 2 decades it was treated as fact. It's still repeated in videos today. But in 2011, a NASA team led by Jack Lasauer ran the same simulation with far more computing power tracking Earth's tilt for up to 4 billion years instead of a few million. Their result was completely different. Without the moon, Earth's tilt wouldn't swing to 85 degrees. It would wobble by roughly 10 extra degrees beyond what we have now noticeable, but nowhere near catastrophic. In other words, the moon helps stabilize our seasons. But it may not be the difference between a living planet and a dead one, like we once believed. Science corrected itself. Most documentaries never got the memo. Even without a climate apocalypse, the losses stack up. For over 10,000 years, human calendars were built around the moon's 29.5-day cycle. Islamic, Hebrew, and Chinese calendars still are today. Harvest festivals, religious observances, entire systems for tracking time all calibrated to something that no longer exists in the sky. And there's a quieter loss. The moon is why our days are 24 hours long instead of roughly 6. Billions of years ago, before the moon fully formed, Earth spun so fast that a single day may have lasted only a few hours. The moon's gravity has been acting like a brake ever since, slowing our spin bit by bit, stretching our days out, century after century. Remove the moon, and that brake releases. Over millions of years, Earth would spin faster again, not something you'd feel in your lifetime, but a real shift in the planet's rhythm. And total solar eclipses one of the only cosmic coincidences where a smaller object perfectly covers a much larger one would be gone. Forever so. Could life go on? Yes, Earth wouldn't explode. It wouldn't drift out of orbit. Humanity would adapt, the way we always have. But surviving and unchanged are very different things. Weaker tides would reshape coastlines and marine food chains. Nocturnal species would face a night hunting crisis with no historical precedent. Our sense of time, literally, how we count days and months, would fracture. The planet would still spin. Life would still exist. But the version of Earth we've always known, the one every ecosystem, every calendar, every tide table was built around, would be gone. It's easy to look at the moon as just a pretty light in the sky, a backdrop. But it's been quietly running the show for 4 billion years, regulating our tides, steadying our seasons, setting the rhythm every living thing on this planet still moves to. Here's my question for you. Out of everything we just covered, the tides, the darkness, the missing eclipses, which change do you think humanity would struggle with first? Drop your answer below. I read every one. If this pulled you in, hit subscribe and like the video. I'll see you in the next one.